A vibrant koi pond is a source of beauty and tranquility, but maintaining a healthy environment for these prized fish depends entirely on one unsung hero, the filter. A good koi pond filter is not just about achieving clear water, it is the critical life support system that handles the massive biological load produced by koi, preventing harmful ammonia and nitrate spikes. Choosing the right one can feel overwhelming, with options ranging from simple submersible boxes to advanced multi-stage gravity-fed systems and innovative drum filters. This essential piece of equipment must provide superior mechanical filtration to remove debris and robust biological filtration to keep the water parameters stable and your collection thriving. Selecting the perfect filter is the single most important decision for any serious koi enthusiast. The essential role of filtration for koi health. A robust filtration system is the absolute cornerstone of a thriving koi pond, serving not merely as a clarity tool, but as the fish's primary life support system. The high feeding rates and substantial waste produced by koi create a massive biological load, demanding a sophisticated and ceaseless purification process. This is achieved through a critical partnership between two distinct yet equally vital types of filtration, mechanical and biological. Mechanical filtration acts as the pond's first line of defense, physically trapping and removing suspended particles like fish waste, uneaten food, and environmental debris before they can decompose and pollute the water. This continuous removal of solid waste is essential for clear water and significantly reduces the organic load that would otherwise overload the subsequent biological stage. The biological filter, however, is the true unsung hero that governs koi health. It provides a vast surface area for colonies of beneficial bacteria to flourish. These bacteria are instrumental in facilitating the nitrogen cycle, which is the foundation of a healthy aquatic ecosystem. The process begins with the bacteria converting highly toxic ammonia, a direct product of fish waste and decaying matter, into nitrite, which is still dangerous to fish. A second group of bacteria then quickly converts the nitrite into far less harmful nitrate, which can be safely managed with regular water changes and plant uptake. Without robust biological filtration, the water would rapidly become saturated with lethal levels of ammonia and nitrite, leading to severe stress, compromised immune systems, and ultimately death for the koi. Therefore, the filter's successful management of the nitrogen cycle ensures stable, non-toxic water parameters, allowing your prized fish to not just survive, but truly thrive. Understanding the three types of filtration: mechanical, biological, and chemical. A truly effective koi pond filter operates as a comprehensive three-stage system, with each stage playing a distinct and critical role in maintaining water quality. This integrated approach combines mechanical, biological, and chemical filtration to manage every form of waste, from large solids to invisible dissolved toxins. Mechanical filtration is the essential first line of defense, dedicated to the removal of visible, suspended solid waste. This includes fish feces, uneaten food, and environmental debris like leaves and sludge, which would otherwise cloud the water and, more critically, break down into ammonia. The process involves physically straining the pond water through a series of media, such as filter pads, brushes, or fine sponges, which trap the particulates. More advanced systems, such as sea filters or rotating drum filters, RDFs, utilize fine mesh screens to remove waste particles down to microscopic sizes before they can even reach the next stage. Timely removal of this solid waste is vital, as it prevents the organic load from overwhelming the biological filter. Biological filtration, as the preceding context detailed, is the heart of the system. Its role is purely biochemical, housing the vast colonies of beneficial bacteria that facilitate the nitrogen cycle, converting lethal ammonia into nitrate. The success of the mechanical stage ensures these bacteria are not smothered or clogged by physical debris, allowing them to focus on processing the dissolved nitrogen compounds. Finally, chemical filtration acts as a polisher, removing impurities that neither the mechanical nor the biological stages can address. This stage is primarily used to absorb dissolved organic compounds, tannins, and other microscopic elements that cause water discoloration, unwanted odors, and can sometimes contribute to poor fish health. The most common media used for this purpose is activated carbon, which uses an enormous internal surface area to chemically attract and lock away these pollutants, resulting in the pristine, crystal-clear water prized by koi hobbyists. Chemical media is generally used intermittently or exchanged regularly, ensuring the final stage of filtration delivers the highest level of water purity. Gravity-fed versus pressurized filters. Which system is right for your pond? The choice between a gravity-fed and a pressurized filtration system fundamentally dictates the layout, scalability, and long-term efficiency of your koi pond's life support. These two architectures represent distinct approaches to moving and cleaning pond water. Pressurized filters are typically the solution for smaller, less demanding water features or casual ponds where aesthetics and ease of installation are priorities. In this system, a submersible pump located in the pond pushes water through a sealed canister, which contains the mechanical and biological media before returning the clean water to the pond. Their major advantage is versatility. The compact unit is highly space-efficient and can be easily buried or hidden above the water level, allowing for flexibility in landscaping. However, forcing water through dense media under pressure can be energy-intensive, and their smaller size generally limits their biological capacity, making them less ideal for heavily stocked or larger koi ponds where waste load is significant. In contrast, gravity-fed filtration systems are often considered the gold standard for dedicated larger koi ponds. In this setup, water flows out of the pond, typically through a bottom drain, and into the filter chamber solely by the force of gravity, meaning the filter's water level must be even with the pond's surface. After passing through the filter media, a separate pump returns the clean water to the pond or a waterfall. This system is significantly more energy efficient, as the pump only has to overcome the head pressure of returning the clean water, not the resistance of the entire filter media. Furthermore, gravity-fed filters are larger, offer superior flow rates for better processing of heavy koi waste, and integrate seamlessly with bottom drains for optimal mechanical debris removal. While they require more complex initial plumbing and space for the larger filter chambers, their robust design and efficiency make them the definitive choice for the serious koi hobbyist aiming for pristine water quality at scale. The critical importance of UV clarifiers in koi pond systems. While a robust, gravity-fed filter system represents the apex of mechanical and biological waste processing for koi ponds, it is inherently incapable of achieving one crucial aspect of water quality: complete visual clarity. This is where the ultraviolet UV clarifier becomes a non-negotiable component, serving as a vital finishing stage in the filtration process. Mechanical and biological filters excel at removing solid waste and converting harmful ammonia and nitrite respectively, but they are powerless against the microscopic organisms responsible for green water, free-floating single-celled algae. The UV clarifier is installed after the main filter chamber, typically on the pressurized return line created by the energy-efficient pump. As water passes through the unit, it is exposed to a high-intensity UVC light source. This light penetrates the cell walls of the floating algae, damaging their DNA and rendering them unable to reproduce. The now dead algae cells clump together, becoming large enough to be easily captured by the mechanical filtration media upon their next cycle through the system or settling to the bottom for removal via the bottom drain. For the serious koi hobbyist aiming for the pristine water quality mentioned in the context, a UV clarifier is essential not just for aesthetics, but also for observation. Green, pea soup water obscures the fish, making it impossible to quickly spot signs of disease, fin damage, or stress, critical early warnings for maintaining a healthy and valuable koi collection. Integrating a properly sized UV clarifier ensures that even the largest, most heavily stocked koi pond retains crystal clear water, completing the work of the gravity-fed filter by delivering the ultimate level of clarity and visual health inspection capability. How to properly size your filter system based on pond volume and fish load. Properly sizing a koi pond filter system hinges on two critical variables, the total pond volume and the density of your fish population, known as the fish load. The goal is a system that can mechanically remove solids and biologically convert harmful ammonia and nitrite faster than your fish can produce them. A serious koi hobbyist must always oversize their filtration. The initial calculation dictates the required flow rate. A standard rule of thumb for a high-quality koi pond is that the entire water volume should pass through the filter system at least once every hour. For example, a 5,000-gallon pond requires a pump capable of delivering a net 5,000 gallons per hour (GPH) to the filter, accounting for head loss from plumbing friction and elevation. However, a simple flow rate is not enough. The fish load drastically increases the required filtration capacity. Koi are large, messy fish that produce a substantial bioload, and a common stocking density guideline suggests aiming for about 1 pound of fish per 10 gallons of water. For a heavily stocked or maturing pond, the biological filter must be significantly larger than what the manufacturer rates for a lightly stocked pond of the same volume. To compensate for a high fish load and to ensure pristine water, the filtration system should be selected based on a pond size that is 1.5 to 2 times your actual volume. If you have a 5,000-gallon pond, you should install a filter system, including mechanical and biological stages, rated for a 7,500 to 10,000-gallon pond. This oversizing provides crucial reserve capacity, maintaining water quality even during peak feeding times, heat waves, or when your koi grow larger, ensuring the health and clarity required for a valuable collection. Choosing the best filter media for optimal biological performance. The necessity of oversizing your entire filtration system for a high koi bioload must be paired with selecting media that maximizes biological performance within that enlarged space. A larger filter body is only effective if its chosen media provides an exceptionally high and protected specific surface area, SSA, for colonies of nitrifying bacteria to thrive. The primary goal is to ensure the rapid conversion of toxic ammonia and nitrite even during peak feeding or environmental stress, a function critical to the reserve capacity built into an oversized system. For modern high-performance koi ponds, moving bed biofilm reactor (MBBR) media, such as Caldness K1 or its variants, is a premier choice. This media is designed to be tumbled in a dedicated chamber, a process which sheds the oldest, weakest bacteria and excess sludge while retaining a thin, highly efficient biofilm on the protected internal surfaces. This continuous self-cleaning action prevents clogging and ensures consistently high oxygen availability for the bacteria, making it exceptionally reliable for handling the substantial, fluctuating bioloads of a heavily stocked koi pond. Alternatively, high-porosity sintered glass or ceramic media offers a different approach, boasting one of the largest protected SSA values per volume. The highly porous, labyrinthine structure provides sheltered areas that are less prone to shearing from high flow rates, allowing beneficial bacteria to colonize deep within the material. Traditional media, such as Japanese filter matting, remains effective, offering a balance of biological and mechanical filtration and is a staple in multi-chamber filter setups. Ultimately, the best media choice directly impacts the viability of the oversized filter strategy. Utilizing media with superior SSA ensures that the 1.5 to 2 times capacity you install is not just a larger box, but a genuine workhorse, providing the necessary reserve capacity for pristine water and a healthy, valuable koi collection. Top 5 features of a high-quality, good koi pond filter. A high-quality koi pond filter is the cornerstone of a healthy aquatic environment, moving beyond mere water clarification to become a sophisticated life support system. While the choice of superior filter media is critical, the structural design and operational features of the filter unit itself are what unlock that media's full potential. The first essential feature is integrated multi-stage filtration, meaning the unit must seamlessly combine effective mechanical pre-filtration, robust biological filtration, and, ideally, a powerful UV clarifier. Mechanical separation must be the first line of defense, removing particulate matter before it can reach and clog the biological media. The second feature is appropriate sizing and flow rate capacity. As emphasized by the oversized filter strategy, a quality unit must be rated to handle a flow volume significantly larger than the pond's turnover rate, often requiring a filter capable of processing higher volumes to maintain the necessary reserve capacity. This excess capacity is vital for smoothing out the substantial fluctuations in a koi pond's bioload. Third, exceptional ease of maintenance is paramount. Given the volume of waste generated, the filter needs to be cleaned regularly, so a high-end unit will feature intuitive backflush, rinse, or semi-automatic self-cleaning systems to minimize owner labor and ensure beneficial bacteria are not disturbed during cleaning. The fourth hallmark is durable, weather-resistant construction. Components must withstand constant water exposure, UV rays, and external temperature shifts without degrading, ensuring a long operational life. Finally, and directly related to the performance of the chosen media, is effective mechanical prefiltration and protected biological zoning. The filter's design must isolate the settlement and mechanical stages, like brushes or sieves, from the biological zone, which houses the high SSA media. This isolation prevents solid waste from blinding the media, preserving the maximum surface area for nitrifying bacteria and allowing the filter to process ammonia and nitrite reliably, even under peak bioload stress. Essential partner equipment: pumps, skimmers, and bottom drains. A high-performance koi pond filter, no matter how advanced, cannot operate in isolation. Its efficiency is directly dependent on a trifecta of partner equipment: pumps, skimmers, and bottom drains. These components form the crucial network responsible for collecting waste and ensuring constant, effective water circulation, which together drastically lessens the bioload stress on the main filter. The bottom drain is the most critical component for prefiltration, as it is strategically placed at the lowest point of the pond to remove heavier-than-water solids, primarily fish waste, before they can decompose and saturate the water with ammonia. In sophisticated systems, these drains are often part of a gravity-fed setup that sends the heavily soiled water directly to a settlement tank or sieve, protecting the main filter's mechanical stages from being overwhelmed. Many high-end designs feature aerated bottom drains, which release air to gently lift and carry debris towards the collection point, while also providing deep water oxygenation. Complementing this subsurface cleaning, skimmers are installed at the water's edge to capture floating debris such as leaves, dust, and uneaten food, which would otherwise sink and contribute to the bottom waste load. By removing surface organic matter, skimmers prevent this material from decomposing and introducing additional sludge into the system. Finally, the pump is the engine of the entire system, dictating the crucial flow rate: how many times the pond's total volume is passed through the filter per hour. For optimal performance, a high-quality, energy-efficient pump must be correctly sized to match the filter's processing capacity and the pond's turnover requirements. Utilizing a dedicated pump for the main filter flow ensures consistent water movement, which is vital for delivering an uninterrupted supply of ammonia and nitrite-laden water to the protected biological zones for nitrification. The synergistic operation of these three components is what allows the main filter to maintain the water quality required for a healthy koi habitat. Step-by-step guide to filter installation and setup. Proper installation is the final, critical step in ensuring your koi pond filter system operates at peak efficiency. The process begins with strategic component placement. Position the main filter unit, especially if it's a box or gravity-fed model, so that its outlet is at or slightly above the desired water return point, such as a waterfall or stream. This placement allows filtered water to flow back into the pond naturally. The pump should be positioned to receive water efficiently, either submerged near a bottom drain pickup or, if external, plumbed directly to a feed line or skimmer. Next is the plumbing connection. The pump's outlet must connect directly to the filter's inlet. Use properly sized UV-resistant hosing or rigid PVC piping with secure clamps or solvent welds to ensure leak-proof connections. If your system includes a skimmer, its water capture line is routed to the pump intake. It is often best practice to dedicate one pump solely to the filter system to maintain the consistent flow rate required for effective nitrification, as opposed to sharing a pump with features like waterfalls. Before introducing power, prime the pump and filter. Submersible pumps are self-priming once submerged, but external pumps require the pump housing or strainer pot to be manually filled with water to avoid running dry and burning out the motor. Once primed and all connections are secured, you can power up the pump. Allow the system to run for a few minutes to ensure steady flow and check for any leaks. Finally, the biological media setup is crucial for long-term water quality. Any new mechanical filter pads or sponges should be rinsed with water to remove manufacturing residue. The biological media itself must be cycled. This involves inoculating the media with a commercial liquid or powdered beneficial bacteria starter to accelerate the colonization of nitrifying organisms. This seeding process is vital and can take 4 to 6 weeks to complete, during which time the filter establishes the necessary bacterial colonies to process fish waste. Maintaining low fish stocking and light feeding during this initial period is essential to avoid new pond syndrome and ensure a successful biofilter foundation. Routine maintenance and deep cleaning for long-term filter efficiency. Achieving a high-performing koi pond filter relies on a consistent, differentiated maintenance schedule that addresses the unique function of each media type. The long-term efficiency of a filter system is governed by a dual-pronged approach: frequent cleaning of the mechanical stage and infrequent, delicate care for the biological stage. Routine maintenance is centered on the mechanical media, such as filter pads, sponges, and brushes, which are the first line of defense against solid waste. These components should be checked and cleaned weekly or biweekly, with increased frequency during warmer summer months when fish are fed more and produce more waste. Cleaning the mechanical media prevents the accumulation of sludge, which can quickly clog the filter, reduce water flow, and ultimately starve the biological media of oxygen, severely impacting the system's overall capacity. Conversely, the biological media, bioballs, ceramic rings, or lava rock, requires a cautious, less frequent approach. As the home to the beneficial nitrifying bacteria, these components should only be deep cleaned every 3 to 6 months, or only when absolutely necessary, such as when flow is significantly restricted. The cardinal rule for this task is to never rinse biological media with chlorinated tap water, as the chemicals will destroy the bacterial colonies essential for processing fish waste. Instead, media must be gently agitated and rinsed using dechlorinated water, or preferably a bucket of water drawn directly from the pond. This technique removes excessive sludge without completely stripping the vital biofilm. For comprehensive long-term efficiency, a thorough seasonal deep clean of the entire system is recommended at the start of spring and the end of autumn. This involves a more extensive purge of sediment from the filter housing and connecting pipework. Regular selective maintenance not only ensures crystal clear water, but also prolongs the effective lifespan of the filter media, contributing to a robust, self-sustaining biofilter foundation for the health of your koi. Long-term koi pond filter efficiency hinges on a strategic 2-stage maintenance routine. The mechanical media, acting as the first line of defense, requires frequent, often weekly cleaning to prevent clogs and maintain optimal oxygen flow. Conversely, the biological stage, home to essential nitrifying bacteria, demands cautious, infrequent care, typically every 3 to 6 months. The cardinal rule for this stage is to never use chlorinated tap water. Media must be gently rinsed with pond water or dechlorinated water to preserve the vital biofilm.
By adhering to this selective maintenance, complemented by seasonal deep cleans, the filter system sustains a robust, self-sustaining biofilter foundation for crystal clear water and optimal koi health.